All right, haven't been making any videos in a while, been really busy. Last time I made a video, I think it was making some castings over here, which now it's November, almost Thanksgiving, a week from Thanksgiving, and trying to get safety valves done so I can test them in the boiler that's sitting right here out of the camera. In the last several years, doing it in cold weather, and I didn't want to do that again, but I'm going to be in the cold weather, but not too bad. Before I'll probably be able to get it before Christmas. Last year, a couple years before that, I was doing them in January and threatening to snow and all. So that had a lot to do with one of the reasons why I'm now making my own castings, is because I can never get them on time. But this year, you know, setting it up took a while and getting the feel of how to do it and all of that. So now I'm pretty good at it, not too bad. Learning more about it all the time. And next year I'll start in April, making my waxes, getting them treed up in May. By May I'll be making the castings. By June I'll have all the castings made and getting ready to machine them up. And this year, 2016, I'll be able to do them in a decent weather. So, been making safety valve parts, made the heads. Here's the heads here. Here's one of them. I got 50, almost 60 of them done. These are just some of them. There, see them there, and got them all machined out. Now these are all done on the Hardinge chucker, which is right over there, and I did the valves as well. Here's the valve right here, a little poppet valve, so on, and I did those on the chucker. And it started out with a casting like this. This is the casting, one of the castings I made. I somehow didn't get that one machined. But that's the casting. Now what I do with this piece on the end here, that's the tooling. So I machine that, and then it fits in a collar, and I face it and turn it, and then it goes in against the stop, and then I do this side, then turn it around, and then cut that off, and do the rest of it. And I save this piece here, and what I do with that is, I drill a hole in there, 3/32 hole, and I splice off two discs, and that becomes part of this, which is the spindle for that's a stem spindle for the spring goes in this area here, and this goes down inside of that valve, like this. And then the spring sits on top of that. Now this piece rides in the bottom of the hole. It's radiused in there. I made a radius D-cutter to do that. And everything's now precision. And what I'm working on at the moment is I'm gonna, I'll show you the piece that I'm making over here now, which is part of the deal. But this is a piece that I made up. That's 1/8, the biggest diameter is 1/8. The smallest diameter on my right is a 1/16, and the larger, second largest diameter, this diameter is 3/32, which is about 0.90. And I'm just getting set up to do that. Now how I did that was I used this tool right here, which is called a hollow mill. And you see the end of it, it goes right over right over that, boom, done. And it works out pretty good. I'm going to do them in the DSM-A, and then I take a piece, the brass piece, I put it over the top of that. I'm going to get one over right over here. I'll get one and show you. I got a whole box of them here, a whole bucket full of them. They were the remnants of that. End of the valve. So now I just silver solder that together, and then I machine it. That saves me the trouble, and I'm not wasting those parts. Well, I wouldn't waste it now. Nowadays, I would remelt it down. But there's another tool now I want to talk about. They're called box tools. Boyer Schultz makes them. And they're roller box tools, like two little rollers similar to a steady rest, and then a cutter goes in here, and there's some pretty fancy grinding that has to be done on that cutter. And I ground it by hand now. I didn't know anything about this, and I had to get in touch with my buddy the Tubal Cane, and he put me on to a few places, and then on the internet. And with that, I found another guy who's down in Tampa, Florida, who sells a tool called a DT Tool. It's the name of his company, Daryl, whatever his last name is. And I just got done talking to him on the telephone, and he makes a tool to convert those to carbide tipped. So I'm going to buy one of those, and then I'll have a carbide tool, and it'll more accurate. I don't have to worry about grinding it. It's a negative rake tool with a positive chip breaker. So that means for a $10 tool, it's like a diamond shape, you know, like a parallelogram. You get 4 cutting edges. So if you buy $90 for 10 of them, that's $9 a piece, and you get 40 cutting edges. It's not bad. And I have another tool that fits that for doing some of my other stuff, for doing wheels and whatever. I use a lot of that for doing a lot of turning at one particular tool. So I'm going to look into doing that, getting that stuff done. But in the meantime, what I've been making over here is, and I've got, I don't know, let's see, at the moment, I got 256 of them, because I got the counter up there now. That's within 10, because sometimes you mess up and whatever, but this is right here. That's what I've been making in there. And you say, well, what is that? Well, that's what they call the blowdown ring. Now that's not knurled on there, that's cut. I got 45 grooves around there, and I did that over on the Bridgeport. And drop one down on the floor. One less more I gotta do. Get it back. Okay, geez, can't bend down anymore. And I got another bucket here full of them. And I figured, I only need, I'm only gonna make 50, 60 valves right now. But I figured, hey, I got this machine set up. It took me 3 hours to get the tools ground, get everything all set up. I figured, well, what the heck, I might as well run a bunch more. So I went down to McMaster Car, and he said, well, why are you buying a McMaster car? It's gotta be expensive. Well, maybe it is a little bit more expensive, but where are you gonna get 11 16ths OD brass? Tell me where you're gonna get that from. Online Metals don't have it. McMaster Car carries it in 32nds of an inch. So I get the proper size. I don't have to worry about turning it or nothing. It's 18 inches long when I get a 36-inch long piece. I cut it in half. I machine the end of it like this, and I put it in my indexing. I have a vertical index with a center on the end, and I actually cut these grooves in there. There's 45 of them around there. And if you try to knurl it, knurling puts a lot of pressure. It's just too much aggravation. So now I got a whole bunch of them in here. They come off the machine, and I'm going to set up to thread them. They got to be threaded with a 1/2 inch 40 thread. And I'm going to use I got go, no-go gauges. I've got the ring and the plugs, and I did those heads the same way. I did that with that thread that's in here is a 3/4 32 thread. I have the ring go and no-go and the plug go and no-go. And that's the way you have to do things, because then it's standardized. Everything's standard. I'm not guessing anymore. This is the first chance I've had to make safety valves with my new Hardinge chucker, which is right behind the camera, and a good old DSM-A over here, which is a really great machine, believe me. And I'll show you one of the heads with the, let's see, where's one? Okay, here it is, run right here. Here's one that I made up. I got to do these next. I had some left over from before. That's the base, and then this is the valve goes in there, and then this is what they call the blowdown ring. Now you want to see when they reseat, and like you'll see them reseat with a couple of pounds. Boom. Well, that's how it's done with this little ring. And what I found out about the ring is it's got to be a pretty smooth thread, a pretty good thread, and I made them now wider. I made them thicker. Rather than 1/8 of an inch, I went to another 30 thousandths wider. because it's a little bit more stable on the mating thread. And I went from a 32 thread to a 40 thread, which is a little finer adjustment. So what I've been doing, and it's been working out great. My casting setup is pretty great. And by the way, I want to mention, before I get into running the DSM-A, because there's going to be a lot of noise, the air compressor is going and blah, 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 blah. I'm going to tell you that I'm learning 3D modeling. And I have SolidWorks. Well, I got it. I'm going to tell you where I got it. I couldn't grasp the concept, believe me. And then I have Inventor, Autodesk Inventor. Somebody gave me a copy, and I have problems with that. Now I have Autodesk, which is called Fusion 360. And I was able to get that. I watched, there were some very, very good YouTube videos about it. You want to watch those, you look up Fusion 360 tutorials. And the program, if you're an entrepreneur or you're a company that makes so much money or not enough money, whatever, you read it, it tells you, you can get the program for free for 1 year, and then you have to buy it there. It's cloud-based. And I've already tried to make a few things, and I want to get something and show you what I made my first project, and I'll be right back. All right, close the door here. We hear the noise in the other room. But this one, my very first 3D project, and it's, like I said, it's a Mercer spanner wrench. And it fits the nuts that are used on my, if I can hold that there, on my starter valve. And I'm going to, like I said, I'm going to powder coat them, and they're going to be made out of die cast, which is plenty strong enough. It's going to break. If it breaks, you tighten the nut too tight, my opinion. So I'm going to give it a try. I think it's fine. I'll test them over here in the vise. I'll put something in there and see if I can break it. And that's going to be an item I'm going to offer for sale. Anyway, I'm going to run the DSM-A now, and we'll see, get that running again. I'll tell you, what a great machine. Well, I just run 300 pieces. Jeez, no problem at all. Just run them. All right, now I got to remember the sequence on how to put this on. Let's see. We'll start with this. Okay, that's the main thing. And make sure you put the air on, which is over there. You got to make sure you put the bar feed air on, which is right here. Okay. And you start the thing up, and it should start running. All right, let me see. We got the coolant. Yeah, the coolant's on. Coolant is oil, actually. Let me see. All right, there we go. All right, you've got to cut out the first piece. It's going to drop into the bin. All right, that's going to feed out. Close the collet again. Face off a little bit. All right. Now it's going to, we'll call it pseudo center drill. It's really not center drilling much. Going to go through a couple of dead stations there after the drilling. Now I got the drilling set on a deep drill cycle where it cleans out. You don't have to do that, but I have it already set that way, so I use it. I'm in no hurry. What I've been doing is I have an extra security camera, and I put a security camera on it, and while I'm watching it in my office, which is about 100 feet away. I've been doing drawing while I'm watching this machine run. There's the 2 dead stations, 3 of them actually, I'm not using. Now it's going to come in chamfer, reverse tool, upside down. Just cuts the corner off a little bit. Now it's going to come out, cut off. Boom, another one bites the dust. Start another one. Alright, that's a little demonstration on the DSM-A again. I love that machine, I'll tell you. It's not a CNC, not computer driven. It takes a little bit more setup. It takes a little bit more brains to figure this out. I don't have to sit there on a computer and figure it all out. The machine here is a manual automatic, I guess you would say. But you know what? For the money you can get these, I've seen them. I got a deal on this one, but you can get them for $3,000 to $4,000. A lot of tooling. I've got probably another $2,000 or $3,000 in tooling. But you know what? I understand this machine. It runs beautifully. The spindle accuracy. I just turned out 300 pieces. And I pull any one of these out of the box here and just check it. They're exactly the same. All exactly the same. No problem whatsoever. It's great. And so that's what I've been doing for the last couple of months. Getting these ready. I'm machining parts. Going to be doing some other pieces, getting them all ready, starting to assemble them, getting them out of here. I'm doing about 60 valves, which will give me about 30 pair. Not everybody buys pairs. Some people buy one. But generally speaking, they sell in pairs. So, okay, that's it for now. Thanks for watching my videos, and we'll see you again on the next one.